I'm going to invite Yamen to the stage now. Yamen is a partner in the platform engineering business inside Deloitte to give a slightly different perspective of what are the things that are getting in the way of building great software and delivering great experiences to your customers or your citizens. So Yamen, welcome to the stage.
Thank you, Anthony. Cheers. This is not quite going to be a TEDx talk, but I'll try to bring some of that energy to it. So Yamen Slater, Deloitte, work in a team called Platform Engineering. Let me see if this works. There we go. We help make companies young again, which I think is a logo we must have come up with before I had kids, because now that I have kids, I realize young again is not necessarily a compliment. But you know, modernization, agility, what most organizations want, because I think what you have largely is this inability to change, this feeling like you're old and creaky. In the enterprise anyway, we see how Amazon builds things, how Spotify builds things, and you just imagine trying to bring that back to your environment, and there's this dissonance, like there's no way we can quite change. And what is that? So we're kind of a weird bunch in technology, because if I was to go outside this room, say the word legacy, it's a beautiful word. It's what you leave behind. It's what your kids will remember you for. It's legacy. It's lovely. Then you talk to a technologist, and that's legacy. It's the reason why nothing will work. It's the scapegoat. We could do this if only it wasn't for our legacy systems, our legacy approaches, our legacy teams, our legacy culture. And in a way, legacy is the problem, but what is it really? Because code doesn't rust. The age of a system doesn't mean it's going to necessarily slow down. So what causes these impediments to actually delivering software faster? So what I want to go through today was 7, calling them Antipatterns, and some antidotes to resolving kind of this issue of speed and software delivery in the enterprise. Why 7? I could be dramatic and say it's the 7 deadly sins. It's not that. Basically, I want to be specific enough that you can actually take something actionable out of this, ideally, although some are bigger than others. And not so reductionist that you just come down to this issue of, the issue is people, or the issue is money, or the issue is time. Of course, those things are issues, but it is a lot more specific than that. So, let's get going. I've got a countdown here, so I'm going to try to be snappy. We'll get through all 7, and then maybe what we can do about them. So, the first. Now, it's a lot of words. I say legacy isn't the problem, but sometimes it is. We have legacy systems that do some very important work in our organizations. And the problem isn't having a legacy system, right? The problem is the anti-patterns that we see around the use of that system. So roughly 2, as I categorize them there. One is the legacy system that keeps growing. We need to use it. We need to use it in a certain way, but what we keep doing is tackling new requirements onto that legacy system in a manner that couples the new functionality to the legacy and makes anything new that we've built also legacy. The 2 are coupled together. Or the legacy system is being used in a way that all new requirements are built directly into it. So either coupling to it or built inside. So it grows. We never get past our dependency on this system. The other is what I call the stagnant legacy system. It's a legacy system where we're kind of codependent at that point. It's got us hostage. We don't even try to think about how we can make life better in it. We just accept things the way they are. So, the mainframe system that still uses ways of working that are from 3 decades ago. So the processes are as legacy as the system itself. And the other is the legacy that's been miscategorized as a legacy system. It needs to be fast. You can't just quite contain it, but you've never put in practices to make it go fast. Typical example we see in this space is the CRM. We treat it like a system of record because it may be slow to change, but the reality is it's involved in every bit of transformation you're trying to do, and so it slows the entire environment down. So what do we do about these? There's two approaches. One, take a two-speed approach. Try to abstract away from the legacy. We have APIs and event-based architectures that can wrap your legacy in a protective blanket and let you build around it without being coupled to its speed of change. All of these antidotes, by the way, are going to sound really easy. Everyone in the audience is going to be nodding, going, yeah, that's easy to say, hard to do. Agreed, none of these are straightforward, but it's still worth knowing the catalogue of things that you can do. We can offload certain processing from the legacy system, offload query loads into operational data stores, offload transactional loads by starting to break the legacy system using microservices. All we're trying to do there is pull out the legacy, the fastest parts of the legacy system, and make them stand by themselves. Or you can go with the faster speed approach. How do we actually make the legacy system a little bit more modern? So if you have a mainframe in your organization, there are mainframe modernization technologies. You can actually run CI/CD and automation on a mainframe. Something I learned about a year ago we've been doing successfully at clients. Or of course, you can go to the antidote that most of us know, which is we better replace this system. It's far down on the list. That's the growing legacy. Second one I'll talk about is the hospital pass. This is where change in any reasonably sized organisation needs participation of many teams. The hospital pass is one team passing to another, passing to another, passing to another, and none of those teams can really do something effective by themselves to progress value in an organisation. So the team boundaries are set up such that at least 2, 3, 4, 5 teams are needed to achieve any reasonable technology-oriented outcome. Those boundaries often don't align to any business value or system. And more often than not, the way these teams coordinate isn't through self-service platforms or technology. It's often through meetings and documentation. And, oh, no, not that documentation, this one. Oh, but the guy there, you should get him in the room as well. Probably the most common pathology of an organisation is this structural one. Also, the hardest one to change, because this one does need broader alignment between technology teams and business teams to fix. But there are known models of how to fix this. Better alignment between systems and team boundaries and kind of the way a business already operates to reduce those handoffs. I'll talk a little bit later about sort of the role of platform teams in terms of providing shared services and business-oriented multifunction teams that can actually deliver value by themselves. But when we do the assessment on clients as to where they find the greatest bottlenecks in delivery, this is often number one. Third one, the project. Organizations are large, and sometimes to steer a ship from one direction to another, you do need this transient bit of funding and structure and external support, sort of all bundled together to achieve an outcome. We call that a project. And projects in and of themselves are not bad. Sometimes they are necessary in order to fund something that is large enough to make a major change. But there are some red flags when it comes to projects. We know that a project structure can get in the very way of agile delivery, because a project structure and the way funding happens means that requirements need to be known up front, solutions are known up front, people are resourced up to a time frame, and that's delivered, which goes very much against what we've learned in terms of building good software, which is that it's a bit more continuous, a bit more agile. So it can get in the way. Projects are usually funded for building. You sprint and sprint and sprint, you get to the end stage, you've built the thing, and now ongoing run and maintenance is going to be someone else's concern once the project is dissolved. So you get a lot of challenges with funding because it's just for build. Success. Project success is measured by on time, on budget. It's never on time, on budget, but even then, that's not really the measure of success. I mean, success is often tied to some business outcome, some KPI, and projects don't typically keep going to actually meet that outcome. And the project structure is the way the teams are brought together, the way the responsibilities are handled, the way work is handed off, is not often reflective of how things are going to run ongoing. So whatever was working while it was in the project, eventually, especially towards the end, immediately gets dissolved, everyone goes back to their teams, and now has to be able to operate this system and its architecture and its processes within the normal organization structure. Antidotes. A lot of these can be tackled individually. For organizations that find themselves relying on technology on a more ongoing basis to deliver value. And that's most, but not every part of an organization. Let's say the parts of an organization that rely on technology to deliver business value constantly would benefit from what we call product mode realignment. Standing funded teams that are capacity constrained to deliver value over time with proper alignment and accountability for business outcomes. And they are not technology teams. I mean, the alignment with business kind of means it cannot be a technology team. It's a combination of technology and business, and with enough depth down the stack to actually enact change. So very similar to what I was talking about earlier with the organizational realignment, those boundaries often become loosely termed products. The Gandalfs. Any organization that is serious has to have in place some controls that allow it to meet its obligations to customers operationally, to regulators, to law, to its employees. And those control structures are built up over time and out of necessity. And often, they become the responsibility of teams and people. So I say the Gandalfs, I don't mean it disparagingly, because they are wise and necessary, but it's the you shall not pass approach that really gets in the way. What we find is that these necessary functions have two issues. One is that they are too far to the right. What I mean by that is, in the delivery process, there tend to be, after detailed design or build, or sometimes test, more often than not, these are just a pre-release check. So they're too far to the right to actually allow delivery velocity, and they're too manual. These things are done as checks by people as opposed to governance as code. And so, the antidotes are kind of the opposite of that. We can shift left on security and ops, and there's platforms and approaches that allow us to do that. And we can shift left on ops, and the ultimate shifting left is to have DevOps teams themselves. But these are not always necessary to actually achieve improvement in this area. And these days we see a lot of clients who want to enable their organization to have, say, self-service usage of the cloud. And they struggle to do that because, again, it's all gated. These days, it's possible to take a dual risk approach. Some things should be gated and checked before they go to production. Some things can be watchdogged after they go to production. Continuously watch what's happening and then react based on the level of risk with a particular check. So, avoid the Gandalfs, the standing in the way, avoid gates. If you have to have them, shift them left, and try to introduce some watchdogs on the right-hand side. The production snowflake, I won't spend too much time on this one, everyone knows it. The more your production system is a unique and wonderful snowflake, the more likely you are to never be able to achieve delivery velocity, because velocity is kind of dependent on trust. Trust is dependent on quality. And you can't get quality if you don't have an ability to know that things are going to work before you hit production. Of course, there are great techniques for testing in production and recovering quickly from failure. I know a lot of the businesses we work with simply cannot afford failure or that type of testing in a lot of their business domains. So it really does become about getting better and faster at quality engineering and testing. This is one of the probably the most underinvested areas we find that our clients. Test data management is just challenging. It becomes something a project can do Very hard to do in a BAU mode, therefore very hard to do sort of with standing teams. Synthetic transaction testing is very difficult. Standing up test environments on demand and tearing them down, very difficult. Having developers have test-like environments on their laptops, very difficult. And so often you can sprint really, really hard, and then you hit SIT and UAT. And other than the obvious bottleneck that we hit when we get to those environments, the insufficient ability to really test beforehand means the quality isn't great when we get there. And so, it's hurry up and wait when we get to testing. So there's no single answer here. There's a lot of tools that help with test virtualization, test data management, do so in kind of a secure and private manner, automation of test environments, standing them up on your laptops, obviously using tools like PCF or PKS to allow a bit more congruency between development and test and production. There's many techniques here, but often watch for this bottleneck. It gives you a hint that this is where the issue is. The fear of code. I'm hoping no one in the room is in an organisation where there's fear of code by virtue of you being here, but this is, I think the higher up you get as an executive, the more you don't want the, your future and your success in the hands of developers. Developers as a necessary evil leads to this kind of fear of code. We would just want off-the-shelf platforms or things that we can configure, and it feels like a greater security blanket. Obviously, this sort of false binary option, it's just buy or build, is a little bit binary. There's a spectrum there. You can buy, you can adapt that existing system, you can integrate a few different systems and some external services to achieve your outcome, you can extend the system that you already have, or you can build. So there's a spectrum there. And there is a downside to using proprietary platforms and SaaS offerings and extensions there. It's tremendous lock-in, resources are very, very hard to find. Those technologies often have significant constraints on how they're used. And so there's a false economy to using those versus writing code. So what's the antidote? Well, we need to make code easier, less scary. And part of that is industrializing how it's done, so that we're not asking all teams to work out everything necessary to deliver value through software. So obviously we're a pivotal conference, standardizing on platforms that you just write value and not have to work everything else out is critical. And we can widely use languages and frameworks, so the idea of there being resource constraints later is alleviated. And of course, we can actually make coding normal. This is the more cultural change. If there are any architects in the room, this is kind of where I look to you. Code is not something to fear because the alternative is not often less scary. It just seems that way when you have to explain it to executives. So we try to make code normal. Language of microservices has really helped in that regard. Not everything's a big, large system that we have to build. Let's just build this little bit of value that we can't do anywhere else and succeed from there and keep moving forward. Last one, the accidentipaz. We're guilty of this. So my team started working with containers. I think we had our first production release for a client back in 2014, I want to say. And, we released some containers, a bunch of microservices actually, for an education client. And they were like, we need to improve the build on this, so we added some build scripting. And like, we need to do some container security scanning, so we added that. We need some service discovery stuff, so we dropped in console at the time. We need to do logging a bit better, so we added Elasticsearch. And over the course of a year, we built a PaaS. It was a very unique PaaS because it was the very specific choices that we'd made along the way. And there's a certain attraction, I think, to very slowly working up the maturity curve of having, say, an industrialized platform which deliver code and software. You say we're over here, we need to get to over here. We do that in steps, step 1, step 2, step 3. The problem with that is you end up spending quite a lot of time deciding, what unique bits of technology you want to put in each of those steps, integrating them together, and then relearning how to deliver with that next step of maturity. This is an area where we genuinely believe today, the answer might have been different 18 months ago, that you can leapfrog a lot of this and just make some opinionated choices altogether to give yourself a platform to deliver quickly, rather than going down the incremental approach and probably spending a lot of time just bike shedding, navel gazing at decisions that are ultimately not terribly important, but feel productive. So don't fall into accident to PAS, just get a PAS. Nice and easy. So, nice and easy, right? This is all you need to perform at a high level. Just contain your legacy systems, enable speed, and organize around domains, and maximize the autonomy of teams, especially with self-service platforms, and shift to product thinking, and low-risk code delivery, and shift left on all those shared concerns, especially security, and only buy 2 pizzas at a time, of course, and measure and monitor everything, and get feedback and adapt, and iterate and iterate and iterate, and you'll be sweet then, right? We know the answers. I think there's nothing, I'm hoping nothing anyone's heard here today is very, very surprising. We kind of know what the end state looks like. We know why. But that well-oiled machine, we're not going to get the chance to just start it from scratch in a whole new organization. How do you get there from where you are today? Ultimately, that's probably the hardest question. Like, where do you start and how? I like a manufacturing analogy when I think about this stuff. Theory of constraints. Who knows about theory of constraints? Very good. Software delivery is not like manufacturing. We're not building the same widget over and over again, but it is in a way like manufacturing because we are trying to get from something on the left to something on the right, and we're only getting value when it's on the right. And more often than not, even though the inputs and outputs are different, the process is largely the same. And so theory of constraints comes from manufacturing largely and lean. And what it says is, there's often a bottleneck in a process, the thing that's slowing you down. And any improvement you make in the process before the bottleneck means work just gets stuck at the bottleneck. And any improvement you make in the process after the bottleneck, well, it doesn't have enough work coming to it to be effective. So you really need to be focusing your energy at the bottleneck. But let's iterate on that. You unblock that, work starts coming through, and there's an inclination to just keep doubling down and opening that bottleneck. But very quickly, there'll be something else that's blocking you. And so we find the approach of being able to kind of identify where your real blockers are, what the right level of investment is to get them unblocked enough to make progress, and then reiterating on that. Moving the dial on a few things all the time is kind of key to making these changes affordable, effective, and sticky, right? And the iteration aspect of this kind of belies the fact that this transformation doesn't happen like that. Alongside theory of constraints for manufacturing, there's value stream mapping, and this one has made it more into the parlance of software delivery, which is, if you can visualize and measure the steps along your software delivery lifecycle, and if you can work out which of those steps are actually value adding and necessarily, they take time, such as actually writing code, versus the ones that are left because there's wait states between teams and handoffs and approvals and checks and rework. If you can visualize all those things, then A, you're able to identify where your constraints are, and B, you're able to systematically start applying the antidotes, the techniques we spoke about, to making improvements. That said, there's probably a couple of no regrets things you can do immediately. I was with my siblings on the weekend, and my brother, who's much younger than me, suggested we get KFC, and because we're adults now, we can just make that kind of decision. And there is a point to this digression. And it was great beforehand, because we're like, we're going to get to eat KFC. And 10 seconds after starting, there's immediate regret. So KFC is my symbol of regret these days. So what are the no regret actions you can take? There's a couple of things we just know are going to make an improvement, and they don't tend to fall into the bucket of, if we over-invest here, we're not going to get a return. So they don't fall into the theory of constraint problem. So we all know we should be having more automation, right? So CI/CD in your delivery process. You can leapfrog a lot of the next steps on that journey if you go straight to a platform, which I'm sure you can hear from Pivotal all about today. But do something there, right? You need to get that pipeline, the actual code to build and maybe unit test pipeline smooth, and then make that path to production nice and straightforward. You can introduce security concerns into the pipeline. So once you've automated, applying a lot of security as code and governance as code into pipelines becomes relatively straightforward. You're not going to get everything done, but your security team will be receiving code that they know has been scanned and checked for vulnerabilities and so on, quite straightforward. Look at testing. Again, I can't really give a very specific thing here. I can just say, look deeply at what causes issues in your testing environments, because no matter what you do elsewhere, you need to fix that at some point. And if you are using tools to track work delivery, start investigating whether you can apply a value stream approach to that. And that often just means looking at reports to see where things get stuck and starting to categorize your tasks so you can visualize and measure those. I think everyone in the world is sort of thinking, won't quite work in our environment. Our people don't think this way. Our culture's different. I would say that you can change practices in a small way. You can't change culture, but you can change practice a little bit. And small changes aren't that hard. And what we largely find is that practice change, the change in practices leads culture change. So when people are operating in a different way, used to operating in a different way, that tends to permeate through the culture. If this kind of stuff is interesting to you, I highly recommend this book. It's excellent. I stole some stuff from it. Anyway, that's me. Happy to talk outside if you can find me.